Hello, today we're going to do section 3.2, which is going to be taking our parent functions that we learned last time and doing transformations to their graphs. This is what creates all of the different members of each family, if you want to think of it that way, so that when we get all of our other types of graphs, this is where they come from. So we are going to be talking about the different types of transformations that we'll run into. That will include your shifting up and down, so vertical shifts. We're going to look at horizontal shifts, which is going left to right. And then we'll also be looking at stretching your graphs and also reflecting them. So we're going to start with doing vertical shifts, which is shifting your graph up and down. So we can take any of those parent functions that we learned last time and just shift them up or down on the graph. So on this example, they're taking x cubed. So remember, x cubed is this little kind of swirly shape. And so what they're doing is they're just shifting it up 3. So the way to tell a vertical shift is you will have your function, and then whatever you're shifting up or down is just going to be some number plus or minus in the back. So the plus means it's going to go up. And then if we minus, like on this one, we have a -4, that means to take your graph and shift it down 4. So look for those plus or minuses for those vertical shifts. And then horizontal shifts are similar. You can take, again, any of those shapes that we learned last time from our parent functions. So this one is your absolute value shape, where you get that V. So the parent function goes through 0, 0, sits on the x-axis right there at the origin, and then you can shift it left or right, up or down. So the way to know if it's a horizontal shift is you're still going to be either adding or subtracting a number to go left or right, but the difference is that is going to be inside the function, and that's kind of tricky to understand at first when I mean it's inside of the function. But notice that this +2 is inside of those absolute value lines. That is going to be your horizontal shift. The other tricky thing with horizontal shifts is if you were to just kind of guess, you would think that +2 would mean to shift it right to, because plus would go in the positive direction, you would think. But it's actually backwards. So when you add, this is actually going to go left for your shift, and when you subtract a number, that is when you do a right shift. So kind of backwards there, a little confusing. So try and remember that. Plus means actually going in the negative direction, and negative means to go in the positive right direction. So on this one, we have the +2 inside those absolute value lines. So we're taking that V shape and keeping the shape the same. We're just shifting over 2 points. And on this one, we have a -5 inside. So here's the origin where that parent function would be starting, and we're just shifting it over 5 to the right. Okay, that's your horizontal shifts. We also have what we call stretches. This is going to be kind of making your graph either skinnier or fatter. So when you have a vertical stretch, the way you are going to recognize this in an equation is it's going to be some number being multiplied in front of your function. So this graph example is for the x² quadratic parabola shape that we learned last time. And notice it's being times by 3. You can kind of think of it as a slope. If I have x² and I'm timesing it by 3, it's going to be 3 times as steep. So it's going to be skinnier or steeper when we actually sketch it out. To make it a fatter graph, so looking at this one, here's our parent function, just a regular x² parabola. The new function, look how it's kind of a wider bowl shape. That comes from the fraction being in front. So if you multiply by something between 0 and 1, so like a fraction or a decimal, that is going to make it a fatter shape. So again, if it's a whole number, it's going to be a skinnier one. And if it's a fraction or a decimal, it's going to be a fatter shape. So you can kind of think of this 1/3 as your parabola is going to go up only 1/3 as fast as it normally would. So it's going up slower. So that is going to be your vertical stretch. Again, it's just going to be that number being multiplied in front of your function. And then the last one we're going to look at are your reflections. So you can reflect two ways. You can reflect across the y-axis. So here is the square root of x parent function that we learned last time, and it has been reflected across the y-axis. So you can just kind of think of taking that mirror image and flipping it over. Versus this bottom one, we still have that parent function, but this time it's being reflected downwards across the x-axis. So notice how these two are written. They both have a negative inside of them, so those negatives are going to mean your reflections, but where that negative is at is going to depend or tell you which way to reflect it. So if the negative is on the inside of the function, so here we have that negative inside of that square root, that's going to be your reflection across the y-axis. If the negative is in the front of your function, and this is probably the more common case you will see, if it's in the front and not inside of the square root or the whatever function you have, that's going to be your vertical reflection where you're going across the x-axis. So top to bottom. And these ones I think are more common than these ones, but you will run into those horizontal reflections every once in a while. So those are your transformations. We're just going to do some practice here where I give you a parent graph and then there's some different transformations up here along the top. And we're just going to practice doing those to each of these different parent functions. So this first one is just f of x equals x. That's your line, a linear function. The parent graph just goes right through the origin and it has a slope of 1. It's going up 1, over 1, up 1, over 1, up 1, over 1. So then on this column, we are doing the transformation. What this is saying is take your function f of x and subtract 2 from it. So that subtract 2, notice it's on the outside of the function, on the outside of the f of x. This minus 2 is going to be your shift down 2. So rather than have, and I might draw the parent function going with a dashed line, rather than going through 0, 0, we are now going to go down 2, and that line is going to keep the same slope. We're not changing the slope at all, we're just shifting it over. So here would be our new graph. So we have that shift down 2. Okay, if we look at this column, we have x plus 3. Notice the plus 3 is inside the parentheses. This is different than if I just did x plus 3 on the outside. I know it's kind of confusing when it's just an x. So when it has this plus 3 inside parentheses versus not inside parentheses, this is saying you have your horizontal shift. So this plus 3, remember the horizontal shifts are kind of backwards to what you would think they are. Plus 3 actually means to go left 3. So rather than have our graph going through 0, 0, there's the parent function, we would move it over 1, 2, 3 places to the left. And again, we're keeping that same slope, it's just we're shifting that over. And I'm not very good at drawing a straight line, but that's close enough. Okay, so we've just taken that and shifted it over 3. Okay, let's look at this one. So notice here, we have the negative f of x. That negative is in front of the x. It's not inside these parentheses right here. So this is going to be one of your reflections, but when the negative is on the outside of the parentheses, that's where you flip over the x-axis or your vertical shift or reflection. So think of folding it backwards. So if here's my parent function going through 0, 0, and I'm reflecting this going from top down to bottom, instead of going up from here, it's going to go down from here. And instead of going down from here, it's going to go up from here. So that is going to be your reflection. And with a line, they all kind of look the same because you just have a line. But when we get into some more of the complicated functions, it's kind of easier to tell the difference between the reflections. So this one, we have another reflection, but notice that negative is inside the parentheses. When it's on the inside, that's the one where you flip over the y-axis versus this one you flipped over the x-axis. So we have our line. There's our original parent function, but this time I'm imagining flipping it this way. So instead of going up to the right, it's going to go up to the left. Instead of going down to the left, it's going to go down to the right. And notice that they look exactly the same. So again, that happens when you get a really symmetrical line and it doesn't change very much. Okay, so far we've just done one reflection or one transformation at a time. We're now going to kind of put some of them together. So if we look at this equation right here, this is what it's telling us to do, kind of the general format up here, and this is where they're applying it to the actual function that we have. Notice that we have that negative in the front. So that negative in the front is going to be your vertical reflection going across the x-axis. We have a +1 inside the parentheses. When it's on the inside, that's your horizontal shift, so going left or right. And then we have a +2 on the outside of the parentheses, that's your vertical shift, so we're going to shift it up 2. So we're going to reflect across the x-axis. We have a +1, which means we're going to shift it left 1, and then a +2 on the outside means we're going to shift it up 2 for your vertical shift. So I'm going to just do the parent function, just so we kind of have a base to go off of. We know we're reflecting it. I usually do my reflection last so that we can get the shift first. So let's shift it first. We know we're going left 1 and up 2. So instead of being at 0, 0, I'm going to move it over 1, left 1, and then up 1, 2. That's going to be my new point. So instead of being centered here, I'm going to center it here. And then we are reflecting it, remember? So if I reflected this, right now, before the reflection, it would just be a dashed line going in the same direction as the parent function, but we're going to flip it upside down. So it's going to flip and go this direction so that we have the opposite slope. So we've shifted it over 1, up 2, and we've reflected it so that it's flipped upside down. So that's just with a line. I do think the lines are probably the easiest parent function that you can use. But let's try a harder one. I don't think we'll do this whole paper just because it would take forever for a YouTube video. Let's do the x cubed one. Okay, so we're starting with x cubed. I'm just going to draw the parent function again. It's kind of like you have half of a parabola going up, and then instead of finishing the other half on the other side, it flips down. So you have kind of like two halves of a parabola to get kind of this little swirly shape. So that's what x cubed's parent function looks like. It's centered at 0, 0 for the parent function. But then if we look at this column, so remember up here, it said to do the -2. So we're going to write this equation out. We're taking our parent function, x cubed, and we're going to do the -2 on the back. So it's not inside any parentheses. So what this is saying is if you have your parent function, I'll do that in the dashed lines again, we're taking this shape and we're just shifting it down 2. So rather than being at 0, 0, we're going to be at -2 on the y-axis. And then we're just doing that same shape, but then it's going down. So kind of got cut off on that line, but that's okay. Okay, let's move over to the next one. So on this column, if we look at the top, this was the x plus 3. Notice the +3 is inside parentheses. So when we want to do the inside of parentheses with an x cubed, we're going to have to do the x plus 3 in parentheses, and then that cube, that power, goes on the outside like that. So it would be the same if we were doing x squared as well. You're going to put the plus or minus number on the inside of the parentheses, and then the square or the cube will go on the outside. But having that +3 on the inside is important because that's what tells us that it's a horizontal shift versus a vertical shift that we were just doing. So remember, it's backwards. +3 doesn't mean to go right 3, but actually means to go left 3. So we're going to be centered over here at -3. And let me draw, here's the parent function shape again. Just kind of give us a reference point. We're going to do that same shape, but just over 3. So there's our shape. Okay, let's move on to the next one. So on this one, if we look at the column, this is where we had the negative f of x. Notice the negative is in front of the f of x versus on this one, the negative is inside with the x. This is your vertical shift or reflection where you flip it upside down from across the x-axis. When the negative's on the inside, that's where you flip it left to right across the y-axis. So we want to do across the x this time. So that means when we write our equation, we have our x cubed and the negative is going to go in the front with no parentheses. So we get a negative x cubed. So here is our parent function again. Just draw that really quick. And then we are reflecting it from top to bottom across that x-axis. So this half is, instead of going up, is going to flip going down. And this half, instead of going down, is now going to go up. Okay. So this next one over was just the other reflection where the negative is going to go on the inside. So you're going to do the parentheses and then negative x in parentheses. And then that cube will go on the outside. And here's our parent function. So again, we can take this one and the negatives on the inside, it's going to take it and reflect it across the y. So this half up here is now going to flip over into this section, and this bottom half is going to flip over into the right side. And notice again, they look kind of the same. That's going to happen on your ones that have an odd symmetry where they reflect and they look kind of the same either way. Okay, this last one, this is where we had the long equation that did the combination of all of the different parts. So when we want to write that, we had the negative in the front, so I'm going to do the negative first, but then it had x plus 1 in parentheses. So I'm going to do the x plus 1 in parentheses. And here's where we're just going to add that cube to the outside of those parentheses. And then it had the plus 2 on the back. So we have our negative, we have our plus 1 on the inside, and then our plus 2 on the outside. That negative on the outside in the front is going to be your reflection from top to bottom, so across the x-axis. The plus 1 on the inside, that's going to be your horizontal shift. So a plus 1 means to go left 1, and then a plus 2 means to go up 2. So here is our parent function shape, just for reference again. So instead of going through 0, 0, I'm going to do my shift first. I think doing the shift first is easiest. So I'm going to shift it left 1 and then also up 2 so that our center is now right here. And if I didn't have a reflection, I would just draw it to be the same shape as this guy. But we're also reflecting it. That negative is telling us to flip it upside down. So rather than have that top half go up, this top half is now going to go down. I'm not worrying too much about actually getting the points in an accurate spot. We're just kind of doing a rough sketch. And so the bottom half going down is going to go up. So we get kind of this little swirly shape. I didn't do a very good job, but hopefully you guys get the idea. Okay, so that is how you would do an x cubed. And then let's do the square root of x really quick as well, just because this one's not a symmetrical one. So I want you to see one like that. So here's a square root of x, the parent function that we learned last time. It's kind of like half of a parabola, starting at 0, 0, and then bending. So it's like half of a parabola that got turned on its side. So on this first one, it's telling you to do the minus 2 on the outside. So you would take the square root of x and then have the minus 2 in the back. So that minus 2 is not underneath that square root symbol. Notice how that square root line stops and it doesn't extend over the 2. So we're going to take that parent function, which is this shape, and instead of just being at 0, 0, we shift it down 2. Then we're just going to keep that same shape. So here would be our new graph. Okay, the next column, it told us to do the plus 3 on the inside. So for a square root, that means to do the plus 3 under the square root. So like on this one, I made sure to tell you don't draw that square root line over the 2, because then it wouldn't be a vertical shift. If you draw the line over it, that means it's a horizontal shift. So we want that line to extend over the 3 this time. So here is our parent function. Remember, it's backwards for horizontal, so +3 means to go 1, 2, 3 to the left. So we're centered here now, and we're going to do that same shape, and then it will just extend. So we're seeing more of the graph on that one. Okay, the next one was your reflection with the negative out front. So for a square root, that would look like a negative and then the square root of x. So notice that the negative is out front. So if here is my parent function, when the negative's out front, that means to reflect it over the x-axis. So this one's going to flip down, and it looks kind of like we finished our parabola. Versus this one has the negative on the inside that we did. So that means we are going to take the square root and then have a negative x in there. And so if here is my parent function, when the negative's inside, that means it's going to reflect it back this way. So you can see a little bit more clearly on this one, since we don't have as much symmetry like we did on the x cubed. You can see easier that this was a vertical reflection. It flipped over the x-axis, where this one flips over the y. And then the last one's the big one where we put it all together. We have a negative out front, a +1 on the inside, and a +2 on the outside. So to apply that set of transformations to a square root, you're going to do the negative in the front, and then you have your square root, and we'll do the x +1 inside the square root lines. And then that +2 is going to be at the back, and the square root line does not go over it. So only the +1 has the square root line over it. Let me kind of zoom in a little bit better. So this negative right here is telling you to reflect it down, so across the x-axis. The +1 that's underneath the square root tells you to shift it left 1, and that +2 on the outside means to shift it up 2. So if this is our parent function, we're going to shift, again, I like to do the shifts first. Let's shift it 1 to the left and 2 to the right. And then if I didn't have a reflection, I would just draw that same shape going up to down. But we have that negative here, so I need to think of reflecting it down across. So instead of going up and bending over, we're going to go down and bending over. And again, I'm not being super accurate on where we're actually crossing the axis, but just kind of a general idea. So we've shifted it over 1, up 2, and then also reflected it upside down. So hopefully you guys feel okay with that. We didn't see any vertical stretches on those. I have those down here on the last row. Let's just do one really quick. Let's do not a line. That one's an easy one. Let's do the square root again. So we have this 1/2 being multiplied in front of the square root of x. That's going to be your stretch. So if my parent function does this general shape, when I times it by 1/2, essentially we're kind of saying we're going to go up as half as slow. So it's going to be kind of like you're squishing down that graph to make it kind of flatter. So it's going to go up about as half as fast. So that would be your new graph. Versus, look at this absolute value one. Again, the absolute value ones are where you draw the V shape. There would be your parent function. But this is saying we're timesing it by 5. It needs to go up 5 times as fast. So I would have a way steeper slope here, and then it will just kind of reflect and be the mirror image on the other side. So again, I'm not being super accurate and actually counting out the slope, but just kind of the general idea. That 5 is going to make it go up faster, whereas a fraction is going to make it kind of slow down. So hopefully you guys feel okay with those different shifts. Just kind of as an overview.